Show that the derivative of f of x plus g of x, which is the sum of two functions, is the derivative of the function f plus the derivative of the function g. We're going to use the shorthand notation for the derivative, which is f plus g prime of x equals f prime of x plus g prime of x. Assuming that f of x and g of x are differentiable, meaning f has its own derivative and g has its own derivative as well, and so suppose f and g are differentiable. What that means is that f prime of x equals the limit at h go to 0 of f of x plus h minus f of x over h, and g prime of x exists, and it is the limit at h go to 0 of g of x plus h minus g of x over h. What this means is that every time we have a limit of the difference quotient of the function g, we would write g prime of x. And similarly, every time we have a limit of the difference quotient of the function f, we would write f prime of x. And so, if we want to find the derivative of the sum, we would start out with the limit definition of the difference quotient of the sum, meaning f plus g prime of x by definition is the limit as h go to 0 of the difference quotient of the sum, which is f plus g of x plus h minus f plus g of x over h. The limit definition of the derivative of any function is the limits of the difference of quotient of the function. In this case, the function happened to be f plus g. This is the limits at h go to 0 of f of x plus h plus g of x plus h. This is how we evaluate the sum of the function. We add the two functions at that input. Similarly, minus f of x plus g of x over h. And then we use an algebraic manipulation trick. This is the limits at h go to 0 of f of x plus h minus f of x plus g of x plus h minus g of x over h, where we just simply use the distributive property and rearrange the terms. We have the negative inside of the sum f of x plus g of x. After we distribute it, we would end up with negative f of x and negative g of x. The common denominator is h, and so we will split the fraction or the rational expression into two. F of x plus h minus f of x over h plus g of x plus h minus g of x over h. H is the common denominator, so if we were to combine these two terms, we would end up with the previous term. But from the limit law, we know that the limit of the sum is the sum of the limits, and so this is the limits at h go to 0 of f of x plus h minus f of x over h plus the limits at h go to 0 of g of x plus h minus g of x over h. But if we have the limits of the difference quotient of the function, then we can simply write the derivative, and so the first term with the limit, this is f prime of x plus, and the second term is a definition of g prime of x. And so what we just show is the derivative of the function f of x plus g of x is separately the derivative of the function f of x plus the derivative of the function g of x. The derivative of the sum is the sum of the derivative. We can change this justification. We can change the justification slightly from f plus g to f minus g, and we will come up with the derivative of the difference is the difference of the derivative.